Hey, AP Statistics. Today we're going to get into quantitative data. We did categorical in section 1.1. We'll come back to categorical eventually much later in the year. We really kind of focus on quantitative for a while because there's a lot more little things we can do when we're working with numbers. So we're working with numbers, but numbers that are quantities. So remember that things like zip codes and other label numbers like that, you wouldn't actually take like the average of numbers that wouldn't make sense to do math with. We don't class, they aren't quantitative actually, so that can be a little bit of a trick. And then the other thing you can do is you can take quantitative numbers and make them categorical by just giving categories, giving ranges. So you can do that. You can't really do it the other way properly for most of the time. So we're going to look at graphs today for summarizing quantitative data. We're going to do this first part of this section. So you want to be able to make and interpret dot plots, stem plots, and histograms of quantitative data and identify the shape of a distribution. We'll do the rest in the next video. So a dot plot shows the value, each value as a dot above this location on a number line. So the steps to doing this: draw a horizontal axis draw a horizontal axis, a number line, and label it with the quantitative variable. So here we're going to be labeling this with goals scored. Scale the axis from the minimum to the maximum value. You don't need to go outside your range. Maybe you show where 0 is if you're kind of close, but you don't. It's not a requirement. But here we're going from 0 up to 10 to cover our range of goals scored by these individuals. And then each individual gets a dot, and we just kind of stack them up. And so we don't label a y-axis. There kind of is a hidden y-axis here where it's just like the number of dots. And you got to be consistent with those distances so that the tallest stack of dots is where there are the most, so we can actually see distribution. Remember, distribution is the values that it takes and how frequently it takes those values. So we kind of see these values down here a little more frequent, and these ones up here. So we put a dot there and just stack them up. It's kind of like a bar graph, but the bar graph can be a few different things. We'll get to the histogram, which is a type of bar graph. But this is nice because it does preserve the original data. We could turn this back into a raw data set if we wanted to. So that is a dot plot. So then if we want to describe shape of a distribution, so we see kind of how those things stack up here. There's a shape showing up. We want to be able to describe that shape as it happens. So a distribution is roughly symmetric if the right side of the graph, the containing half the observation with the largest values, is approximately a mirror image. So they're symmetric. So that's one word you can use. We'll add other words here in a moment, but we'll continue to add some throughout the year. But symmetric in shape is one thing you could describe this as. Another term we can have if it's not symmetric, another common kind of distribution we see is a skewed distribution, where one side kind of is a little bit longer, has a little bit of a longer, we call it a tail for that shape. So skewed to the right, if the right side of the bar graph is longer. So see how they kind of measure this out here, that right side is longer. People get this confused a lot, so make sure you understand the direction of the skew is the longer tail. If you kind of looked at this graph, like if you look at the center of it, like the center of the axis, sometimes people think, oh, well, there's more data on the left of like the center of the range, but that's not what skew means. Skew is from the center of the data. So the center of the data is kind of where most of the data values are, where they stack up. The skew is actually to the right. So that would be a skewed right distribution, whereas this would be a skewed left distribution. So people get that confused all the way up through the AP test. Go ahead and get that right in your head now. So the direction of skewness is towards the long tail, not the direction where most observations are clustered. All right, so when we're describing distributions, we want to look for the overall pattern and any clear departures from that pattern. So there are three things that we want to talk about. Really, actually, a fourth thing as well. There's four things. So we want shape, center, and variability. Or I'll sometimes call those shape, center, and spread because those go well together. And I'll sometimes call it the three S's, even though center is spelled with a C for some reason. Don't get me started on C's. So shape, center, and spread. Also, any other departures such as outliers. So there's that different people will also call it, like a way of remembering this, they'll call it like SOC V, or like, yeah, that's there's a couple of them, but yeah, shape, outliers, center, and variability. So just be careful to what you always, whenever you're describing a distribution, you need to give a clear picture of where is the center of this data. How spread out is it? What's the shape of this distribution? And are there any weird things, gaps or outliers and things like that? So make sure you touch on always those things. And then include context as well. Don't just say, oh, the data is this, this, and this. Say, you know, actually mention what we're talking about. So if you're talking about goals scored, make sure you mention the distribution of the goals scored is centered at, and so you can kind of give the distribution, like where the peak is right now. Like we'll get into other fancy measures of center, but right now you can just kind of give the peak. The peak here is at one goal. So we have that for our center. Our variability, so we can kind of describe, or so I guess they're giving shape here first. So the shape, so we have that peak there, and then this was kind of a skew right distribution. This is a little bit of a weird one where there's this gap, and then there's these two maybe high outliers. So they do mention that gap and that, but kind of describe that distribution as best you can. So they do hit on the outliers. Up there at 9 and 10, and we'll look at some rigid definitions for what outliers are, but you know, those are somewhat debatable. And then the median is where they give in for the center. So yeah, the peak is at 1, but the median ends up being at 2, and we'll get into that median measure. But there's other ways of measuring center. So it's centered down here low at like 1 or 2 goals. And it's got that shape, and then so the last thing we need is that overall spread. And an easy way you can cover this is just the range. The number of goals varies from 1 to 10, but we'll get into some other technical ways as we did this. And so then we always want to make sure, did we include context? And this is the answer, yes. So they did talk about goals, games, team goals, so on and so forth. So make sure that you are doing that. All right, so then when we go to compare distributions with dot plots, we want to make sure we touch on all of those things. So we will use, we'll compare centers. We're called compare shapes. We'll compare spreads. So they chose 50 students from each country, from the United Kingdom and South Africa. And here are the dot plots of the household sizes reported by the respondents. Compare the distributions for these two countries. So we want to make sure we compare. They're both centered at about the same spot, right? They both kind of have peaks there right around 4 or 5. And we could give a specific median if we wanted to as an example of a center. But the other features are not the same, and we want to make sure we cover that. So up here, this shape is skewed to the right, right? So we have some households that are much bigger, right? So that's skewed right shape. Whereas in here, it's fairly symmetric. You know, that's pretty good for symmetry. Don't expect perfection from it. We have a fairly symmetric distribution. And then we've got the outlier up here, that we don't have any outliers in the UK distribution of household sizes. And then the spread, there's a wider range, ranging from, looks like 3 up to 26, whereas the UK's ranges from 2 to 6. So make sure that you include all those things. So and then cover that here. When comparing distribution quantitative data, it's not enough just to list the values of center and variability distribution. You have to actually use comparative language, like greater than, less than, or about the same as. So I don't know if you heard, I was trying to get those things in there. So the centers were about the same. The shape, you can just describe how they're different, but the spread, this spread is bigger. Like, it seems obvious, but the AP test really wants you to include words like the spread is bigger that goes from 3 to 26 versus the one that goes from 2 to 2 to 6. So be careful about including those things. And so I think they go through all that here. So yeah, I won't do it again. Hopefully you can pause if you want to see these things. But they cover the shape, center, and spread.